Hello and welcome back to yet another episode in my ongoing restoration of this old Rogers Majestic console. You know, I've done so many reviews on this project, I think I'm just going to skip ahead to where I left off.
Phono on. That's at full volume. Doesn't have the oomph.
Again, it's my own inexperience that got me into trouble here. All of the turntables that I've repaired so far have been the crystal cartridge type. Now these ones produce an output voltage of anywhere between 30 to 100 millivolts. And after reading about the Garrett 100, it produced an astounding 4 to 5 millivolts. Now the crystal cartridge pickup mostly died out by the mid to late 1960s, though Philips did have something called a salt crystal pickup, though we're not going to go into that here. Those who had old stereos and wanted to upgrade to a new fancy cartridge like this one had to get something called a preamp, and these are still being sold today. Most stereo systems just simply built the preamp in. So I need a preamp to finally finish this project off. An audio grade twin op amp will work just fine, but that does have some problems. First I need a power supply for it, as well create a circuit board for it, then find some place to stick the circuit board in the present chassis. And then there's the final problem that I really just want to keep this stereo a tube-based system and not have a mixed transistor hybrid. Well, there are any number of cheap commercial off-the-shelf tube preamps you can get, but most of them, the tubes are really just glowing, they don't actually do any amplification. I could go for one of the really expensive ones, but then again, that sort of goes against the nature of this project. All I need to do is add in another twin triode into my circuit. As long as that triode has a gain of, say, 20 to 30, that should boost my 5 millivolt signal well up into the range where I'm going to get some humph out of the end of it. Now, there are any number of twin triodes I could try in this circuit, the 12AX7 for example. Now, the only problem in this case is heater supply. See, I'm running at 120 volts with these U-type tubes, so that's only 100 milliamps of current. The problem is the 12AX7 needs 300 milliamps at 6.5 or 150 at 12. So that's not going to work for me, as if I do stick a 12AX7, it would only run at 100 milliamps, as the other heater in the circuit would act like a dim bulb current limiter. I could add in a new transformer for 12 or 6.3 volts, but then again the question is where on the chassis am I going to find a place to stick it, and the cost for such a transformer is a little prohibited. So I started to look for another U-class valve. I did find the UCC 84 and 85. Both would kind of work, as the system already has a UCC 85 as V3 in the RF amplifier. But the pop was that both these valves are high mu VHF tubes that are not really good for audio range applications, especially the very small audio signal coming out of my Garrett 100. Point is rather moot, as I don't have any spare ones around, and the only ones I found for sale was a UCC 84 at a rather steep $126. Then I remembered I had this stubby little valve hanging around, the 407A. Now the only reason why I'm familiar with this tube is that I acquired a very large box of tubes from a radio club auction a few years ago, and by chance, I had only just finished sorting out the box a little while ago, checking each tube and getting the data sheets for them. Now the 407 is an odd little valve. It's a medium U triode, and as the name implies, it has a heater voltage of 40 volts. Turns out the 407 was used almost exclusively in telephone exchanges. Why there would be 7 in the box of random TV tubes I bought, I'll never know. I did do quite an extensive search for another circuit that used the 407, and the only thing I found was it was used in something called a negative impedance amplifier. And going by what the reference said, that must have been one of the most common tubes ever made, as at one time there was more than 300,000 of these repeaters in the North American phone system. So that adds up to many millions of 407s. Now, the most important part here is that when I read through the data sheet, is that it can be read at 2 voltages. 40 volts at 50 milliamps. If it was wired in series, you can also hook it up in parallel, so it runs at 20 volts at 100 milliamps, so perfect for me. The application factor is also fine. At 35, that should give me enough gain to get at least 100 millivolts out of this stage, which is more than enough. The first thing to figure out is how to hook this tube up so it runs in parallel. All I have to do in this case is join pins 1 and 9 together and then run it out of 5, and that should give me 20 volts at 100 milliamps. Now to keep things simple, I'm just going to hook up this new valve in series with the other valves. Here is the original heater circuit for valve 3, and this is probably the best place for me to put this new valve. So what I have to figure out now is whether or not I have enough voltage to get all these things in series. Of course, I start with a nominal 117 volts. Next is the 53 volt drop for my resistor. Next, the two 19 volt incandescent bulbs. And then my 26 volt valve. Now all I do is disconnect that valve from the circuit and then insert my new 407 valve in series with it. The voltages add up to 137, so that's a little high. So what I'm going to do is substitute out these unobtainium 19 volt bulbs for some 12 volt bulbs I have handy. Now the only caveat I have with the 12 volt lamps I'm going to install is that they're for 150 to 300 milliamps current. So they will glow a little dim, but they shouldn't affect the circuit in any other way. And the new sum is 123 volts. Now one neat thing about the UCC85 is that it can run perfectly happily between 20 and 26 volts. So if we substitute the nominal 20 volts in here, the end sum is 117 volts, which is smack on. So what's next? Well, first I have to take out those diodes and LEDs and put back in the bulb holders. Now, power hookup for my 407 valve was rather simple. All I had to do for the heater was to connect it at X3, and then I could just take B positive coming from R59 here. And the input from the phonograph was easy enough, as I just pulled it off at this point here for the left channel and this point here for the right channel. Once I had the circuit reverted all back and the pegboard all set up, my first test was to see what my filament voltage would be with the new 12 volt bulbs. I gradually increased the voltage until I get 26 volts crossing V3, all the time checking to make sure that I don't go past 100 milliamps. In theory, that should be about 103 volts. That gives me 17 volts left over, which should be plenty for the new valve I want to add in.
Okie dokie, so I'm all set up. I have taken out my LCD circuits on both sides. Not going to flip her over to show you. Put in a bulb, a 6.3 volt bulb. And according to theory, this should be running at full blast at about 100 volts, not 120. It's an old trick the old technician guys used to do. You start at a low voltage, and we'll start at a low voltage at 50. There's my AC voltage. We shouldn't see that spike any higher. Right? So there's our 6 AC volts. This is coming up. And it's going down. 10 volts. $16, $17. 70 volts, 70, we'll let that sit there for a sec to heat up. So it's 16, we're at 70 volts, we got 16 volts on there. We can take her up to 80 volts, we got 22. Take her up to 100, and we get about 30, which is just about right on. Yeah, 25 to 26. So we're actually getting the correct voltage. So I don't push it past that threshold value, so that's telling me that this arrangement of heaters should work with my new valve. I hope. It's an old trick that the old technicians used to use. They didn't have to do all the math, they just sort of sat there and figured it out.
The next test is much the same. I hook up my 407 in parallel mode to the filament string and measure the voltage drop across V3 while making sure my current does not go over 100 milliamps. And what I'm looking for is that the voltage across V3 never goes much past the 26 volt range.
Okay, so I'm all set up. There's my tube. It's set up to run in parallel, so it goes in on 1 and 9, comes out on 5, so that should be running at 20 volts, 0.1 of an amp. There's my little guy there. It's not reading any AC right now. I'm starting at 75 volts. Turn her on. Oh, see, my light comes up nice, and the light on the other side is okay. Not very bright, but can't do much about that. I get 12 volts at 75, which is about right. Let's go up to 100. Oop. There's 100, getting 25. I'm getting a glow down here in my other tube, which is good. And we'll put her up to 120 and see what we get. Good. That's running fine. Even getting running a little hot. The radio still works. I might have to put one more dropping resistor in there just to drop that down a little bit. It wants 26 at max, but it can run fine at 127, and we're running at 118 now, so that looks perfect. Now I just got to figure out how to get this in there, and we should be all set to go. Yay!
Much later.
So I'm just about ready to start hooking all these wires up, and I put everything in correctly. Let's see, green is my high voltage filament. Yellow is B positive. You only need one lead for B positive because it just goes to the plate and doesn't go anywhere else after that. Then my H left and my right channel. Now I gotta start hooking up my tube.
Well, as there's probably nothing more boring than watching somebody connect and disconnect wires, I think I'll just bring up the schematic for now. We can see what changes I actually did. So here's the schematic, and the changes are located here, so we can zoom in here. You might ask how I chose all the values for some of the passive components. Well, it's pretty simple actually. I went to one of the data sheets, looked up a Class A amplifier and the voltage I was going to use, and simply copied the values for the passive components from there. So let's start with the load resistor AR1 and 2, which are here and here on the schematic, and I ended up with 670K after trying a few different values. The cathode resistors AR3 and AR4 are next, and they're here and here, and I just used the 240 ohms as suggested by the data sheets. Changing this value either up or down, or not even there, didn't really have a noticeable effect, but I decided to keep them in there because it mentions in one of the data sheets that these should be present to keep the cathode bias voltage stable. Next are two coupling capacitors, AC1 and 2, and it's just the standard value I use for coupling caps between tubes, 22 nanofarads. Finally, we have resistor AR5, which I added to the heater circuit just to drop the voltage a little bit so that we get 20 volts and 20 volts on both of the valves. Here I'm taking advantage of the heater property of UCC85, as it can run anywhere from 26 to 20 volts. I figure 20 volts will extend the tube life a bit. Now let's go see the end result.
Okie dokie. Let's see everything here. I can pull it forward a little bit, I think. We're back. Yeah, pull forward a bit. Doing everything shorted. Everything's connected up back there. Power going through. Throw this switch. And again, I'm doing a slow power up with the Variac starting at 50. Oops, pulling an amp. Oop, I'm getting some bulb action over here. No magic smoke. Let's pull in 100 milliamps. 59, 65, 70, 80, still no magic smoke. Get this good light on there. There we go. Up to about 120. Well, we're getting hum, which is good. Let's do a quick check of the voltages. Turn that down for now. Should be from here. Yeah, it's gonna hum. From here to here. 20 volt drop, that's good. From here to here. 29 volt drop, a little high, but I might put a resistor in there. Good. Good, 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 good. Let's see what the B plus is. Let's see, B plus on here is 118, which is nice. Here, 118, which is perfect almost. Good. I wanted about 120, so that's fine. Let's see if we get a record playing on that now. I have to go set up the record player. I'm going to warm that up a bit first.
1 minute, 37 seconds later.
Well, that's not what I want to hear. Ugh. I have to troubleshoot it a bit.
2 hours later.
So I had a chance to play around a bit, and I changed a few things out. I dropped the resistors coming off the back, didn't need those. I went down to a smaller resistor on there, and I found the problem I was having with that very bad noise. As you can hear, it's coming up pretty good now. Bump, bump, bump. And it was grounding issue. So if I turn that record player off, basically goes silent. So that's hum from the record player. I'll have to, once I get it back in and the tube in there, it should all be okay. But that's funny how much a ground loop will screw you up. So if you hear that sound, you know you got a ground loop somewhere, or you're not properly grounded. Of course, with this thing, it's going to be lots of hum just because it's the way it's off. The only other thing I did was I changed the oops, don't touch that. Changed the resistors out for 1 meg, a couple of other values, and I think these ones sound a little better. I'm getting a little less distortion. Anyway, so the next problem is to take that apart and find a way to stick that new tube in here somewhere. Once I get that in, close it up, and I'll find my grounding fault.
Later.
Okay, got rid of the proto board. Now what to do? Well, number one, put everything back together. Take out my LED modification on both sides, so that one goes out. Leave that one in, fix that up. Go in and put it all back together. Put it back up on the bench, get it all cleaned up, and then where to drill the hole. I've looked at this, and of course the best spot is right there. Now lots of room. I'll probably take out all these wires so I don't mash anything when I'm disconnect all of these guys so I don't mash anything when I'm drilling the hole. I don't think I'll need a new board because I'm really not not putting these things out very long, and all the leads in my stuff are nice and long, so I just need to connect these there. The real main concern is this brown one. I have to reroute that, but I can reroute that around here and under there. And then the high voltage I don't really want running near the bottom of my tube, so I might rerun that up around the corner and down there. So I'll probably drill one hole here, and then I also figured, while I got it open, I'll put a fuse in as well over here. So we just have some fuse protection. Not that we need it, but with an extra tube in there that's quite not rare, but not hard, but hard to get a hold of. I'd rather have that protected with a fuse, and that also might get rid of some of the grounding error. I have to be careful to make sure I got my neutral and line correct, because that's what was causing all that humming. It was when I plugged in the record player, the polarity was different on the plus and minus of the, well, I had the a ground loop going on with the grounds because everything wasn't fully grounded in. So I might actually swap it out for a 3-vein plug and make sure the grounding is correct all the way through to the record player, a turntable I should say. But I don't really think I have to do that. I think if I just get it working correctly, I'll keep that in there, but just use a slotted plug, a slotted plug. Don't have to worry about it. Anyway, I will put it back to semi-stock, take out my modifications, and put it back to normal again, hopefully. And then we'll carry on. Drill my holes and carry on. Of course, like I did before, I documented what I have to do and take apart and took lots of photos. I know what goes where. I've got my little pans of parts to put in. We're all set to go. Alright, there's my nice ceramic tube socket. It's going to go in this way. Question is which way to put it in. Now I've got my my line coming off of here, going up. I'm going to run it across there, and that's got to go into 9 or 1 and cross over to 9. 5 has to go over here. So there's 5. So if I put it in this way, that gives me a nice line to 5. Oops. It gives me a nice line to 5. Let's see. That orange, those two have to come that way. This one's got to come down, that one's got to come down from a cap, but I can put a cap straight up to there, put a cap to there, a resistor, and then just a wire to there. And then I've got a ground point there, and I have a ground point here. That should be okay, methinks. Okay, so just stick it right there. Nothing on the other side. Nope, blank space. Ah, right about there. Somewhere about here. Should be fine. Middle dot marks the spot. Yep. And I can drill these holes in after once I get it in. Okay. Let's see. Alright, there's the fuse holder. That can just go anywhere there. And that's got to go off of black. On that side of black coming in. Let's see if that fits in there. Ah, perfect. There we go. Okay. Let's put the holes, pilot holes in now. First, let's get rid of all this iron out of here. Ooh, one tough chassis. We'll vacuum that after. Okay. Oops. I want number 5. Oh, even numbered on the bottom. Cool. That's number 5 there. I want that over here as much as possible. Yeah, so we want it like that. Okay. Flip her over carefully. Mark the spot, then go mark it better. Now to vacuum this out, I should be ready to put the tube socket in, and then put the fuse holder in. Yeah, those holes line up nicely. Good. Okie dokie. There's my tube socket that fits in nice there. Nicely done there. I got my fuse holder over here. I'll take that off for now. I don't want me to put a fuse in there, so when I put it back together I don't forget. Now the only change I made was I put 5 over here, and I'm going to run it through this way, because then it just gives me a little better move to put the other ones in, and I got a better path to ground for the other ones. Just a different way to do it. It doesn't really matter. I could have 5 over here. It's got to go here, but it's easier just to have it here, come across and over to there. Alright, get the working box out again and put everything. Oh, this project is the project that keeps on giving. Ugh. So as I was putting my new wires in here for the AC in, the line in, broke off one of the pins down here. Took me like an hour to get a new one in there, but it's in there now. Fortunately, I have a lot of these old things in the back, which I can just pull off a donor one rather than trying to drill it out and put a new one in. Anyway, onwards and upwards. And of course, you double check to make sure nothing ever came off, like right here. Oops. That little bugger. That's going to be hard to get back in there. Alrighty. Shall we give her a test? I think it's time for another test. Alright, nice 400 milliamp fuse. Should fit in there nicely. Alright, nice and tight. There we go. Let me just check that, make sure it's all connected up good. Okay. Alrighty, let's get this set up to go. Alright, just putting the last of the tubes in. That sits in there nice, doesn't it? Okay. That goes in there. Yeah. This stage in the game, I don't want to get a tube in wrong. And the pièce de résistance, my 407A. Stick that in there. That looks so cute in the middle. Alright, let's get her plugged in here. Speakers. Can't hear much without the speakers. Oops. It's all off. Off. Speakers, yes, speakers. That's power cord. There are the speakers. At least this time I won't have an arc. At least I hope I don't have an arc. That's a little bent. The best one I've ever put in. Alright, speakers are in. The bulb tester on. Okie dokie. Alright, we await the magic smoke. Gulp. Alright. Okay, here she goes.
Eventually.
There we go. Might swap that out for a low voltage bulb. It doesn't seem to want to work.
But you took my trust, cast me aside, never felt so small.
20 volts exactly. That's exactly what we want.
Just like a ghost.
Sounds good.
Heart was dark and barely there.
Oh well, let's put her back in the cabinet and see what happens. Oop. Yeah. Can't do that without a load. Alright, let's stick her back in the cabinet. Okay, here goes nothing. I've got the hum down to a reasonable level. That's not too bad. Let's see if we actually hear some music.
So I got hit by a copyright violation on that particular one. So I tried again with another record. And hit again, and then one more time. With a final warning from YouTube, if I did it again, I'd lose my channel. Even though I was using 40-year-old records, don't use any that are from Time Life, Reader's Digest, or God forbid Motown. Well, nothing really more to add. The console's being enjoyed by my client, and despite being my longest project yet, I actually did learn a lot and did enjoy doing it. Hope to see you next time.